Title: Key Formulations of the Theory of Entropicity, ToE, as first formulated and further developed by John Onamacy Obidi. The theory of entropicity, ToE, proposes a fundamental reorganization of how we understand physical reality. Instead of treating space, time, matter, and energy as the basic building blocks of the universe, the theory begins from a deeper and more primitive concept: entropy as a universal physical field. In this framework, entropy is not a statistical measure or a reflection of ignorance. It is a real, continuous, dynamical field that permeates all of existence. Everything we observe, geometry, matter, causality, and the flow of time, emerges from the structure and evolution of this entropic field. This video presents several key formulations that define the theory of entropicity. 1. The entropic field axiom. The foundational postulate of the theory states that there exists a real-valued scalar field called the entropic field, defined over a differentiable manifold. This field assigns to every point in the manifold a definite entropic value. It is continuous, differentiable, and evolves according to a local dynamical law. In this view, a physical state of the universe is nothing more than a configuration of the entropic field. No other primitive entities are assumed. Space, time, matter, and energy are not fundamental. They are emergent expressions of the entropic field's curvature and evolution. 2. Distinguishability as entropic separation. For two physical states to be meaningfully different, they must differ in their entropic configuration. The theory formalizes this through an invariant measure of separation between two field configurations. This measure must be non-negative, vanish only when the configurations are identical, remain invariant under smooth reparameterizations of the field, and be additive over independent regions. Under these structural constraints, the only possible measure of distinguishability is the relative entropy, also known as the Kullback-Leibler divergence. This result is not a choice, but a mathematical necessity. 3. The minimal curvature of distinguishability. Although the entropic field is continuous, physical distinguishability requires dynamical stability. Stable configurations cannot lie arbitrarily close to one another in the entropic manifold. There must exist a minimum non-zero separation between distinguishable states. When the relative entropy functional is evaluated for the simplest non-trivial case, two uniform configurations differing by a constant multiplicative factor, the smallest stable separation corresponds to a ratio of 2:1. This yields a minimal distinguishability value equal to the natural logarithm of 2. This quantity, ln2, is identified as the Obidi curvature invariant. It represents the smallest possible entropic curvature that can separate one physical state from another. 4. The no-rush principle. Because the entropic field evolves continuously, and according to finite dynamical laws, it cannot traverse the minimal curvature ln2 instantaneously. Any transition from one distinguishable state to another requires a finite amount of time. This leads to the no-rush principle. No physical process can occur in zero time. Reality cannot jump. It must unfold through finite entropic evolution. This principle is not an added assumption. It follows directly from the structure of the entropic field and the minimal curvature of distinguishability. 5. Emergence of space, time, and matter. Once the entropic field is taken as fundamental, the familiar structures of physics arise naturally. Space-time geometry is interpreted as a macroscopic expression of entropic curvature. Matter corresponds to localized, stable configurations of the entropic field. Energy measures resistance to entropic reconfiguration. Time is the ordered progression of entropic change. In this formulation, the arrow of time is not imposed externally. It emerges from the irreversible evolution of the entropic field itself. 6. The entropic manifold as the ground of reality. The theory of entropicity proposes that the entropic manifold is the true foundation of physical reality. All observable phenomena, motion, causality, geometry, and interaction, are derived from the structure and dynamics of this manifold. This perspective unifies thermodynamics, information theory, quantum structure, and gravitational geometry under a single conceptual framework. It suggests that entropy is not born of the universe. Rather, the universe is born of entropy. Conclusion: the theory of entropicity offers a new foundation for physics by elevating entropy to the status of a universal physical field. From this single postulate follow the key formulations presented in this video: the entropic field axiom, the invariant measure of distinguishability, the minimal curvature ln2, the no-rush principle, and the emergence of space-time and matter. Together, these formulations outline a coherent and structurally necessary framework in which the familiar laws of physics arise as effective descriptions of deeper entropic dynamics.